Imagine if we could travel to Mars in not months but minutes. In theory, this is what NASA's new Lightspeed engine would be capable of doing. Going lightspeed is truly the fastest that something can move. And if we want to conquer deep space, being able to move at such speeds is not only important, it's essential. For years now, the greatest minds at NASA have been attempting to figure out a way to get ships moving that fast. So far, nothing concrete has come from all this brainstorming, and that's not surprising. Cracking the code of traveling at light speed isn't easy. It's literally some of the hardest rocket science imaginable. It's something that even the smartest, most powerful brains in the world have yet to figure out. But what if one scientist working for NASA did figure out how to move that quickly? Would that lead the way to the next generation of space travel? Would it radically change the way we move among the stars? Or is it simply just a pipe dream? In today's video, let's take a look at the helical engine, which may or may not be the key to moving through the cosmos at new breakneck speeds. Before we continue, I want to quickly thank the sponsor of this video, World of Tanks. World of Tanks is a free-to-play online multiplayer tank game with over 100 million players worldwide, realistic vehicles and environments that allow players to command history's most powerful tanks and experience combat like never before on PCs. Over 600 vehicles ranging from destroyers to artillery to light, medium and heavy tanks are available at your disposal, allowing you to wreak havoc in style while also contributing to a unique role in the game. You can command your powerful tanks across open fields, deserts, steep hills, forests and urban and industrial zones, as well as play matches in these areas. There are over 40 arenas to choose from. As a result of the model's historical realism and inspiration, it has real-world tank-like features. You can gain experience, modify and upgrade your tank, transforming it into a steel beast capable of taking on any challenge. Download World of Tanks right now using the first link in the description. Use the code TANKMANIA during registration to receive a 7-day premium account, 250,000 credits, the premium tank Excelsior Tier 5, and 3 rental tanks for 10 battles each. Tiger 131 Tier 6, Cromwell B Tier 6, and T-34-85M Tier 6. Make sure to get this offer by clicking the first link in the description. Now, back to the video. It is important to note that as of now, traveling at light speed with the helical engine is just an idea. Even if it's proven to work, we will have a long way to go before we see NASA astronauts shooting into space on the back of one. But what exactly is it? And why is it creating such a buzz among space enthusiasts? The helical engine, designed by David Burns of NASA's Marshall Space Flight Center in Alabama, takes use of mass-altering processes that occur at near light speed. Burns has submitted a document to NASA's technical reports server detailing the notion. So how does it work? As you might assume, it's rather complicated, but it's able to be described in fairly simple terms through this thought concept. Burns describes this concept as a box with a weight inside, threaded on a line with a spring at each end bouncing the weight back and forth. In a vacuum such as space, the effect of this would be to wiggle the entire box, with the weight seeming to stand still like a GIF stabilized around the weight. Overall, the box would stay wiggling in the same spot, but if the mass of the weight were to increase in only one direction, it would generate a greater push in that direction and therefore thrust. A point in Burns' favor, physics does not prevent this mass from altering. According to Einstein's theory of special relativity, objects acquire mass as they approach the speed of light, which is an effect that must be taken into consideration in particle accelerators. In actuality, a simple version of Burns' notion would be to replace the ring with a circular particle accelerator, where ions are rapidly accelerated to relativistic speed during one stroke and decelerated during the other. But Burns takes things a bit further. He believes it would be more practical to forego the box and rod concept altogether and instead use a particle accelerator for both lateral and circular motion. in which case the accelerator would need to be fashioned like a helix, hence the name helical engine. In order to work, this helical engine would have to be large, very large. In fact, it is estimated that it would need to be over 200 meters long and 12 meters in diameter. And it would need to be incredibly strong too, requiring at least 165 megawatts of electricity to create only 1 single newton of thrust, which is roughly the same force as typing on a keyboard. As a result, the engine would only be able to achieve useful speeds in space's frictionless environments. According to Burns, if given enough time and power, the engine may break all records that came before and be the first engine capable of achieving 99% the speed of light. It remains to be seen if Burns' idea has traction and a chance of actually being developed. Indeed, Burns himself admits that there is a lot that needs to be proven about his concept and that it hasn't been reviewed by experts, and thus there may be some mistakes in the math and planning. In other words, Burns' idea is just that, an idea that needs to be built in order to ever become something worthwhile. Burns created quite the buzz when he submitted his idea to the NASA Technical Report Server under the brief, tantalizing headline helical engine. Immediately, people were reading every word and wondering, what if? And while some people protest Burns' concept and think the proposal is far, far away from a sure thing, others think it could continue and grow into the future of interstellar travel. But this isn't the first time that someone has dreamed up a concept around the idea of humans cruising through the stars at such great speed. In fact, many before have toyed with the idea of a light-speed engine and have fallen short. The M drive was NASA's early step into the notion of really trying to develop a faster-than-light engine. Yet we don't hear a lot of talk about the M drive today. So what exactly is it? Why is it so special? And why is Burns' idea gaining so much interest if the M drive is ready to be built? To put it in the most scientific terms, an M drive is a radio frequency resonant cavity thruster concept that was first developed in 2001 by Roger Scheuer, a British chartered electrical engineer with 48 years of experience in the space and defense industries. Internally reflected microwaves are said to generate thrust, in violation of the law of conservation of momentum and other fundamental considerations. The device has been dubbed the impossible drive by the media. Explanations for how the M drive could work go beyond what is known about physics. Perhaps it's interacting with the vacuum energy of space quantum time, despite the fact that the vacuum energy of space quantum time doesn't allow anything to push off of it. There is no official design for this device, and none of the people who claim to have invented it has committed to detailing how it may work as a thruster or what components make it up, making it hard to tell whether or not it's possible. In 2016, NASA's Advanced Propulsion Physics Laboratory reported seeing a modest apparent thrust from one of these tests, a finding that has yet to be confirmed. The force recorded was later shown to be a measuring mistake produced by interactions with the Earth's magnetic field or heat gradients, according to subsequent research. So far, nothing has come close to achieving light speed, and Burns' idea is still being kicked around and examined by experts. But what happens if and when NASA does figure out how to move at such an intense rate? How does that alter the way we fly among the cosmos? Think of it this way. If we sent astronauts to Mars at the speed of light, they would be there in just 182 seconds. That means that they could get to Mars and back again in the time it took you to watch this video. That's radically fast on a scale that is really hard to wrap your head around. It would still take years to exit our galaxy, even moving at light speed, but it would not take hundreds of thousands of years as it does now. So in other words, cracking light speed travel would allow us to visit other galaxies that were once impossible to reach. It would absolutely change how we move through the stars and would open up so many more possibilities. Now you can understand why so many people are drawn to Burns and his concept of the helical engine. If he really did figure out a way to move at light speed, or even close to it, he may be able to change humanity forever. Thanks for watching. If you want to support this channel, then make sure to check out the World of Tanks at the first link in the description. I'll see you in the next episode.